In 1959, 50 engineers in Burbank, California, sat hunched over drafting tables with slide rules and mechanical pencils. No computers, no simulations, no software. Just paper, mathematics, and a 50-year-old aeronautical genius named Clarence Leonard Kelly Johnson, who was asking them to build something that shouldn't exist. The specifications read like science fiction. An aircraft that could cruise, not sprint, cruise, at 3 times the speed of sound for hours at a time. Altitudes above 80,000 feet, where the sky turns purple and you can see the curvature of the Earth. Temperatures exceeding 1,000 degrees Fahrenheit on the leading edges. No aluminum aircraft could survive that. The metal would soften like butter. They needed titanium, mountains of it. And here's where the story gets good. The United States in the early 1960s, the nation racing to put a man on the moon, building nuclear submarines and intercontinental missiles, positioning itself as the technological giant of the Western world, didn't have enough titanium to build the plane. American suppliers couldn't deliver the quantities required. The domestic reserves of rutile ore, the primary source material for titanium extraction, simply weren't there. But the Soviet Union? They had titanium, lots of it. Soviet mills were churning out roughly 70% of the world's titanium supply. The USSR wasn't just a supplier, they were the supplier. The only realistic source for the enormous quantities of high-purity material the reconnaissance program demanded. Soviet mining operations stretched across the Urals, their processing facilities hummed with activity, their export bureaus moved titanium around the globe. They were proud of this industrial achievement. Titanium was strategic. Titanium was the future. And the Soviets had more of it than anyone else on Earth. So let me get this straight. The CIA needed to build a spy plane specifically designed to penetrate Soviet airspace and photograph Soviet military installations. And the only place to get the raw materials was the Soviet Union. Most agencies would have called this a problem. The CIA called it an opportunity. What followed was one of the most elaborate procurement deceptions of the Cold War. Ben Rich, the legendary Skunk Works engineer who later ran the entire division, documented it in his memoir. The CIA conducted a worldwide search and, using third parties and dummy companies, managed to unobtrusively purchase the base metal from one of the world's leading exporters, the Soviet Union. This wasn't a one-time heist. This was a sustained, multi-year operation requiring sophisticated compartmentalization and misdirection to prevent Soviet discovery of where all this titanium was actually going. The mechanics were layered like a spy novel. Rather than attempting to acquire titanium directly from Soviet sources, which would have raised immediate red flags, the CIA created networks of shell companies and utilized non-aligned nations as transshipment points. Third world countries that maintained trade relationships with Moscow became unwitting conduits for strategic materials flowing to California. These dummy operations presented legitimate-seeming commercial purposes designed to slip past Soviet export controls without triggering suspicion. The Soviet trade bureaucracy was vast, proud, and thoroughly convinced of its own competence. Export officials reviewed paperwork, checked quantities, verified destinations, stamped approvals. Everything looked correct. The purchasing companies existed on paper. The stated end uses seemed plausible. The money cleared. Why would anyone suspect that capitalist pizza entrepreneurs were secretly funneling strategic metals to the most classified aerospace program in American history? And the cover stories? This is where it gets beautiful. Colonel Rich Graham, a former SR-71 pilot who became one of the program's most authoritative voices, explained what the Soviets were told about America's sudden appetite for their titanium. Pizza ovens. Commercial pizza ovens. The logic presented to Moscow was that the United States was a lazy country that probably couldn't even cook for itself, and therefore required imported titanium for this mundane domestic application. Think about that for a second. Soviet export officials sat in their offices in Moscow, reviewing purchase orders for titanium bound for America, and their analysis concluded, "These lazy capitalists need our superior metal to cook their fast food." They probably chuckled about it. They might have used it as evidence of American decadence in party meetings. They approved the shipments. The Soviets bought it, literally. Colonel Graham laid out the situation with the clarity of someone who spent years flying the product of this deception. The aeroplane is 92% titanium inside and out. Back when they were building the aeroplane, the United States didn't have the ore supplies, an ore called rutile ore. It's a very sandy soil, and it's only found in very few parts of the world. The major supplier of the ore was the USSR. Working through third world countries and bogus operations, they were able to get the rutile ore shipped to the United States to build the SR-71. 92% titanium. The entire aircraft, longerons, wing spars, fuselage panels, structural members, all crafted from the specific alloy Ti13V11CR3Al, a beta titanium variant that could withstand thermal cycling that would destroy conventional aerospace materials. And nearly all of it originated in Soviet mines, processed in Soviet mills, shipped through CIA front operations to a Lockheed facility in California. Moscow never suspected a thing. Meanwhile, in those same Soviet ministries, intelligence reports were arriving about American aerospace developments that terrified the military establishment. The U-2 had already humiliated them. Francis Gary Powers flew over Soviet territory with impunity for years before they finally managed to shoot him down in 1960. Now, rumors were circulating about something faster. Something higher, something that would make the U-2 look like a crop duster. Soviet aircraft designers were scrambling. The response to the perceived American threat was the MiG-25 Foxbat, an interceptor designed specifically to catch high-altitude American reconnaissance aircraft. The Soviets poured resources into the program, racing to develop an aircraft that could reach the altitudes and speeds they believed the Americans were targeting. The irony was exquisite. Soviet engineers were working overtime to counter a threat that was being built from Soviet raw materials. They were essentially competing against themselves. But getting the titanium into the country was only the first problem. Working with it was about as straightforward as machining a dream. Titanium was so hard that conventional steel tools snapped and shattered within a handful of holes. Drills designed for aluminium or steel fractured almost immediately. The Skunk Works team had to develop entirely new tooling approaches from scratch. They experimented with cutting speeds, tool geometries, lubricants. Everything that had worked for decades in aerospace manufacturing suddenly didn't work at all. And then there was the contamination nightmare. Titanium proved extraordinarily sensitive to chemical impurities. Cadmium-plated tools, standard in aerospace manufacturing of the era, would transfer residual cadmium to the titanium surface. The cadmium didn't just sit there. It initiated a process called stress corrosion cracking that embrittled the material into uselessness. A part that looked perfectly fine could fail catastrophically under load because of invisible chemical contamination at the molecular level. Even shop floor marking pencils contained chemicals that could compromise structural integrity. Chlorine compounds in common cleaning solutions attacked the titanium. Fluorine residues from manufacturing processes caused similar damage. The metal that could survive 1,000-degree temperatures and Mach 3 aerodynamic loads would crack and fail from a pencil mark. The Skunk Works team had to reinvent their entire manufacturing process. They developed contamination-free work procedures, specialized tools without cadmium plating, cleaning protocols that eliminated harmful chemicals. They essentially created a new discipline of titanium metallurgy through painful trial and error, techniques that the broader aerospace industry would adopt for decades afterward. Every time something went wrong, they had to diagnose whether it was a design problem, a manufacturing problem, or a contamination problem. Usually, it was contamination. And here's the kicker about the Soviet titanium quality. It was wildly inconsistent. The initial rejection rate for titanium delivered to the program reached a staggering 95%. For every 100 pounds of Soviet titanium secretly acquired and smuggled into California, only 5 pounds actually made it into the aircraft. The rest was rejected and scrapped, at full cost to the American taxpayer, naturally, since the CIA could hardly file warranty claims with Moscow. "Yes, hello, comrade. We'd like to return this titanium. It's contaminated." "What do you mean, what are we building?" "Pizza ovens. Very precise pizza ovens." That conversation never happened. The agency was essentially paying 20 times the theoretical material cost for every pound of usable titanium. Running a procurement operation where 95 cents of every dollar disappeared into unusable scrap that couldn't even be recycled without risking exposure of the program. The rejected titanium couldn't be sold, couldn't be reused, couldn't be explained. It just vanished into classified disposal. But in Cold War calculus, money was secondary to capability. The operation continued. The shell companies kept placing orders, the checks kept clearing through untraceable accounts, and Soviet ore kept flowing westward to be transformed into America's most classified reconnaissance platform. The CIA formally approved the program, codenamed Oxcart, in September 1959. Just 32 months later, on April 26, 1962, the first A-12 aircraft lifted off from Groom Lake, Nevada. The facility that would later become famous under a different name, Area 51. 32 months. Using slide rules and drafting tables, to build an aircraft that could outrun any weapon the Soviet Union would field for the next 3 decades. Built from Soviet titanium, test pilot Lou Schalk nursed the aircraft through its maiden flight, discovering immediately that this machine operated in a performance envelope unlike anything previously flown. The A-12 was the CIA's aircraft, built for agency operations. The Air Force variant, designated SR-71, would follow with modifications including a second crew position for a reconnaissance systems officer. Between 1962 and the end of production, Lockheed delivered 15 A-12 aircraft, 3 YF-12A interceptor prototypes, and 32 operational SR-71s. Every single one constructed primarily from titanium that had originated in Soviet mines. Every single one built to spy on the people who unknowingly supplied the materials. By the mid-1960s, Soviet intelligence had confirmed the Americans were flying something extraordinary. Reports from radar stations tracking inexplicable returns at impossible altitudes. Fragments of intelligence about a program at Groom Lake. Photographs of strange, dark shapes on runways. But they didn't know the details. They didn't know the capabilities. And they absolutely didn't know where the titanium came from. Soviet air defense commanders faced a nightmare scenario. How do you protect an airspace the size of the USSR against an aircraft you can't catch? The MiG-25 program accelerated, But even as the Foxbat reached operational status, it became clear the interceptor couldn't sustain the speeds necessary for an intercept. The MiG-25 could sprint to Mach 2.8 in short bursts, but the Blackbird cruised at Mach 3+. You can't catch something that's always faster than your maximum speed. Surface-to-air missiles seemed like the answer. The Soviets invested heavily in SAM development, pushing range and altitude capabilities higher and higher. Surely a missile could reach what a manned interceptor could not. Surely technology would solve this American insult to Soviet air sovereignty. They were wrong. Spectacularly, repeatedly, humiliatingly wrong. Now here's something that would have convinced any observer they were watching a catastrophic failure. The SR-71 leaked fuel constantly while sitting on the ground. Not a few drips. Steady streams of JP-7 fuel seeping from panel gaps and joint seams, pooling on the tarmac in quantities that seemed to suggest the aircraft was about to explode. Ground crews became so accustomed to this that they developed procedures specifically to manage the constant leakage. Any spectator witnessing their first Blackbird departure would reasonably assume they were watching a disaster waiting to happen. But the leaking wasn't a flaw. It was the entire point of the titanium design. The SR-71's panels were specifically engineered to expand as the aircraft heated during flight. At ground temperatures, the panels fit loosely, leaving gaps that allowed fuel to seep through. At Mach 3, when skin temperatures reached 500 to 600 degrees Fahrenheit across the fuselage and exceeded 1,000 degrees on leading edges, those same titanium panels expanded and pressed tight against each other, creating an effectively sealed structure. The aircraft literally grew several inches in length during supersonic cruise as thermal expansion took effect. What looked like a leaking disaster on the ground was actually precision metallurgy optimized for a flight environment that no other aircraft could survive. Soviet titanium stretching and sealing exactly as American engineers had calculated it would. The metal that Moscow had exported for pizza ovens was performing thermal gymnastics that Soviet metallurgists would have found fascinating if anyone had told them what was actually happening. The JP-7 fuel itself was another engineering triumph born of necessity. Standard jet fuel would have ignited spontaneously at the temperatures the SR-71 encountered during cruise. Even during ground operations, the heat soak from the airframe could have turned conventional fuel into a fireball. JP-7 was formulated with an extraordinarily high flash point. So stable, you could theoretically drop a lit match into a bucket of the stuff and it would extinguish rather than ignite. The fuel served as a heat sink during flight, absorbing thermal energy from the titanium airframe and helping to cool structures that would otherwise have exceeded their temperature limits. But this stability meant the fuel was nearly impossible to light through conventional means. So the SR-71 required a special starting fluid called triethyl borane, or TEB. This pyrophoric chemical ignited spontaneously on contact with air, providing the spark necessary to light the aircraft's massive Pratt & Whitney J58 engines. Each engine carried a limited supply, enough for only a few restart attempts. If you flamed out over hostile territory and ran out of TEB, you were gliding home. No pressure. The SR-71 entered operational service with the Air Force's 9th Strategic Reconnaissance Wing at Beale Air Force Base, California, in January 1966. From that moment until its final retirement in 1998, with a brief hiatus from 1989 to 1993, the Blackbird conducted intelligence-gathering operations that shaped American understanding of adversary capabilities across 4 decades of global tension. And here's where the vindication really kicks in. The aircraft's altitude capability placed it in an operational environment where normal aviation rules ceased to apply. The SR-71 routinely operated above 80,000 feet, where the sky appears deep purple and pilots can perceive the curvature of the Earth. Twice as high as commercial airliners. Well above the ceiling of any fighter aircraft the Soviet Union or anyone else could field. When SR-71 crews reported descending to 60,000 feet, still nearly twice cruising altitude for a commercial jet, they were often the only air traffic controllers could see in that entire slice of atmosphere. The humour wasn't lost on anyone monitoring the radio. Air traffic control procedures that made sense for normal aviation became absurdist comedy when applied to the Blackbird. The aircraft operated in a realm where descending meant dropping to altitudes other aircraft could only dream of reaching. Soviet radar operators tracking SR-71 missions watched their screens with a mixture of professional interest and personal frustration. The returns were unmistakable. Something was up there, moving faster than anything they'd ever seen, at altitudes their interceptors couldn't reach. They could track it. They could report it. They could vector every asset they had toward it. And they could watch, helplessly, as it completed its mission and departed their airspace without so much as acknowledging their existence. The thermal reality of sustained Mach 3 flight created conditions that would have destroyed any aircraft built from conventional materials. At cruise speed, the titanium skin absorbed so much aerodynamic heating that the windscreen's outer surface exceeded 600 degrees Fahrenheit. Hot enough that pilots discovered they could warm food by placing wrapped items against the interior surface during cruise. The cockpit became a convection oven. The crews in their pressure suits worked in an environment more closely resembling a spacecraft than a conventional aircraft. Soviet titanium cycling through temperature extremes that would have caused aluminium to puddle and steel to warp. Each mission testing the limits of materials science. Each time the titanium held. Each time the aircraft returned home with photographs the Soviets desperately wished didn't exist. On July 28, 1976, Captain Eldon W. Jers and Major George T. Morgan achieved 2,193.2 miles per hour, Mach 3.3, during a record attempt over a measured course near Beale Air Force Base. This record has stood for nearly 50 years. No crewed aircraft powered by jet engines has officially exceeded this speed, making the SR-71 not just a Cold War relic, but an enduring performance benchmark that modern aviation has yet to surpass. But here's the thing pilots have hinted at for decades. The official stated maximum of Mach 3.2 represents the published operational limit rather than the aircraft's ultimate capability. Multiple former Blackbird pilots have made comments suggesting the aircraft could exceed this figure under certain conditions. Brian Schull, among others, has implied in interviews that performance margins existed beyond what official documentation acknowledged. The gap between public figures and actual capability was standard practice for classified programs. What we know is already extraordinary. What remains classified might be more so. Speaking of Brian Schull, during a mission over Libya in April 1986, part of the reconnaissance operations supporting Operation El Dorado Canyon after the Berlin discotheque bombing, Schull and his R's.So Walter Watson found themselves in an SR-71 designated Rapid Rabbit. Their mission was to photograph the aftermath of the American strike, providing battle damage assessment that satellites couldn't deliver with the same timeliness. As they crossed the Libyan coastline at Mach 3 and above 80,000 feet, Schull noticed something unusual on his threat warning display: a missile launch indicator. Libyan air defences had spotted the Blackbird and were attempting an intercept. Schull's response was almost casual. He pushed the throttles forward slightly, adding speed, and watched as the missile fell hopelessly behind. The geometry was impossible for the Libyan weapon. The SR-71 was moving too fast, too high, accelerating away from a projectile that was never designed to catch something built from materials that could survive such conditions. Soviet-sourced titanium, absorbing the additional thermal load as the aircraft accelerated, stretching and heating exactly as designed, while carrying American cameras away from a threat the plane was never meant to encounter. Schul completed his reconnaissance pass, captured the imagery his commanders needed, and returned home without a scratch on the aircraft. Somewhere in Libya, a missile crew was probably explaining to their commander how they'd fired everything they had at a radar return that simply flew away from their best efforts. This pattern repeated itself across thousands of missions over 3 decades. Soviet surface-to-air missile batteries launched over 1,000 missiles at SR-71s during various reconnaissance operations, according to declassified assessments. Think about that number. 1,000 missiles. That's not a handful of attempts. That's a sustained, decades-long effort to bring down an aircraft that refused to be brought down. Every single one failed. The combination of speed, altitude, and sophisticated electronic countermeasures created a survivability envelope that no adversary ever overcame. An envelope made possible by a titanium airframe that the Soviet Union had unknowingly supplied. The Soviets were shooting at a plane made from their own metal, and they couldn't touch it. Soviet MiG-25 interceptors, the aircraft specifically designed to catch high-altitude American reconnaissance platforms, attempted intercepts that consistently failed. The Foxbat that Soviet engineers had poured years of development into, the interceptor that was supposed to restore Soviet air sovereignty, couldn't catch the Blackbird in sustained cruise. The MiG-25 could sprint, but it couldn't sustain. And the Blackbird didn't sprint. It cruised at speeds the MiG-25 could only briefly touch. The standard operating procedure for SR-71 crews when faced with a missile launch was almost comically simple. Accelerate and outrun the threat. In an aircraft capable of sustained Mach 3 plus performance, with a titanium skin that could absorb the additional thermal punishment, there was nothing in any adversary's inventory that could catch them. The Blackbird's response to hostile fire was essentially, "Lol, no." Soviet air defense commanders must have experienced a particular kind of professional despair. Their entire system was designed around the premise that sufficient missiles, sufficient interceptors, sufficient radar coverage could protect their airspace. And then this thing showed up, silent on the radio, visible on radar, absolutely untouchable, and flew wherever it wanted, photographed whatever it wanted, and left when it was good and ready. For 30 years, from January 1966 through its final retirement, the SR-71 Blackbird flew reconnaissance missions that the Soviet Union could do absolutely nothing about. The aircraft photographed Soviet military installations, tracked Soviet submarine deployments, monitored Soviet weapons tests, documented Soviet military exercises. The intelligence gathered shaped American strategic planning throughout the Cold War and beyond. Over 1,000 missiles launched in anger, 0 hits. Not a single SR-71 was ever shot down by enemy fire. And the whole time, that titanium airframe was built from materials the Soviets had cheerfully exported for American pizza ovens. They sold us the titanium. We turned it into the most successful reconnaissance aircraft in history. We used it to spy on them for 3 decades. They launched 1,000 missiles trying to stop it. They failed every single time. And they never knew. Somewhere in the Soviet bureaucracy, there might still be paperwork approving titanium exports for American food service equipment. Somewhere in Russian archives, there might be trade records showing shipments of strategic metals to shell companies that ceased to exist the moment the SR-71 program concluded. The Soviets kept meticulous records. They just didn't keep the right ones. That's not just engineering, that's poetry. Kelly Johnson's 50 engineers, with their slide rules and drafting tables, created something in 1959 that still looks like it came from the future. 60 years later, nothing has matched it. The speed record still stands. The design still appears on lists of the most advanced aircraft ever built. The titanium alloy techniques developed for the program became standard aerospace practice, and the CIA procurement operation became a case study in how audacity and creativity can solve problems that logistics says are impossible. The Soviets thought they were selling metal for pizza ovens to a lazy capitalist nation that couldn't cook for itself. They were actually funding their own surveillance for 30 years. Which raises an interesting question. If this is what we were doing in 1959, slide rules, no computers, buying enemy titanium through fake companies, imagine what's flying now that we don't know about. Subscribe for more stories like this.